This is a tutorial on conducting a chi-square goodness of fit test on a one-way contingency table. So the first thing we want to do is we want to copy our variable of interest, in this case classification, move it to a new spreadsheet, and then we're going to create a contingency table, a one-way contingency table of this data. So we're going to select that column, go to Insert, go to Pivot Table, and we're going to put this on the existing worksheet. So we're just going to select an area. We're going to click OK. So we have a pivot table in our pivot table builder. I'm going to drag classification into rows as well as into values. And we now have our one-way contingency table with the counts for individual classification groups. All right. So now with this data, with this contingency table, we can do a chi-square goodness of fit test to assess whether there are equal proportions of each of these classes. So to do this, the first thing we want to do is we want to set up an observed group, an expected group. These are going to be tables. We also want to have a table for our chi-square scores. Okay, so we're going to copy our rows. We're going to go ahead and get rid of this blank there. All right. So we're going to enter in our observed for our observed table, as well as our total. And then we can calculate our expected. Now our expected values are going to be equal to the grand total divided by the number of categories, because we're assuming that there are equal, the null is that there are equal proportions in each class. So to get our observed for freshmen, we're going to say this is equal to the grand total divided by the number of classes, in this case 4. So we get our expected count of freshmen, 19 in this case. Now since we're going to be using the same grand total, we can fix this using Command T and then just repeat this operation for the rest of the expected table. So we expect 19 individuals in each class. Okay. Now we need to calculate our chi-square score for each classification. To do this, this is going to be equal to the observed minus the expected. We're going to square this difference and then divide it by the expected. Now again, we're using the same expected value each time because the expectation is 19 for each classification. So we can fix this using Command T for both the grand total in the numerator and the grand total in the denominator. And then we can just click on the lower right-hand box and drag down, and it'll repeat the calculation of the chi-square score for each of the classifications using the appropriate observed value from the observed table. So now we have our chi-square scores for each of our classes. So we need to get a chi-square stat, our chi-square test statistic. We need to get our degrees of freedom, and we need to calculate a p-value. So the chi-square stat is just going to be equal to the sum of our individual chi-square scores. So we have a chi-square stat of 55.0526. Degrees of freedom are going to be equal to the number of categories, in this case 4, minus 1. So we get a degrees of freedom of 3. Our p-value, the way we're going to get this is we use the chi-dist function. We input our chi-square value first, and then a comma, and our degrees of freedom. Hit return, and we get a p-value, very, very small p-value, in fact. Now another way of running this would be to use the built-in chi-square function in Excel. So we can do a chi-square goodness of fit test this way as well. And the way we would do that is, again, let's just make a row for our p-value. The p-value calculated in this manner would be equal chi test. And then we've put our actual range first, so this is going to be our observed values. Then we put a comma, and our expected range, so the values from our expected table, close parentheses, and return. And again, we see that we get the same p-values we did through our manual calculation.